Okay. Hi, everybody. Welcome. Thank you for joining us for the Vermont Ag Water Quality Partnership's Lunch and Learn webinar series. We are excited to welcome Erin Lane today, who is a climate ecologist with the USDA Forest Service and the Northern Research Station, who's here to talk about the New England Climate Hub, Climate and Connection. So thank you for being here with us. As a friendly reminder, I'm just gonna share the vision, purpose, and mission of the partnership. Our vision is that farms will be populated throughout Vermont that are vibrant, robust, and sustainable, and that they steward their land to improve water quality, wildlife habitat, for the benefit of the farms, connected ecosystems, the public, and general good of Vermont. And we seek to improve ag water quality in Vermont by coordinating partner efforts in providing education, technical, and financial assistance to the farming community. And we have three overarching goals to do that. So the first is that we'll improve ag water quality and wildlife habitat on all engaged farmland owner and operators' properties, that we will deliver technical and financial assistance in an efficient and effective way, and that we will provide the best service experience possible for the landowner. So this webinar is recorded. We'll be posting it on our website in our blog spot for all the previous recordings. And I will be posting a survey in the chat. So please make sure you do that before you go. And with that, I'm going to hand it over to Erin. Thank you so much for being here. Oops. All right, I can see your slides.
All right, thanks for having me. It's a pleasure to be invited back somewhere. So I am, as Ali mentioned, a climate ecologist with the Northern Research Station of the U.S. Forest Service, and I serve as the Deputy Director for the USDA Northeast Climate Hub. So you're going to hear a little bit about the Climate Hub today. And we're also going to talk about climate change impacts specific to our region, and I try to focus on Vermont where I can, so that we can think critically about how these changes will and have already affected agricultural production. And finally, I'd like to make some connections to the changes in impacts, how we're adapting, what the strategies are, and provide a sample of tools and resources that we can use to help examine the data, to search information, and to make decisions about management and assessment, both of the present and the future situation. I'm hopeful that some of this information can help the partnership in providing the technical assistance that you do, and ultimately reaching the vision that Ali pointed out, which is similar to our own. We have regional hubs covering the country, and the hubs are designed to develop and deliver science-based, regionally specific information and technologies to inform climate-informed decision-making. And our intention is to work with technical service providers, in some cases more than the actual farmers. And the reason for that is that we don't have the capacity to reach all farm and forest landowners and producers where there's already a structure set up of technical assistance through land grant extension, through many of our own agencies, and through folks like you all, like the partnership. So we represent a unique collaboration, we like to say one USDA, across our department. So we have contributions from the Forest Service, where we host this hub. There's other hubs that are hosted through the Agricultural Research Service. We also work really closely with the Natural Resources Conservation Service. They are co-leaders in our hubs. And then we have connections through other agencies as well, like FSA, RMA, ERS we recently collaborated with, APHIS, and others. So what we do is we try to support farms, forest managers, and waters too, so aquaculture as well, through research and extension to try to understand how the climate's changing and how to deal with it. So we share and deliver information and tools, create tools that are useful for climate adaptation and, in some cases, mitigation as well. So the hubs are structured around these 3 work streams where we are, and we have priority areas among these work streams, but we are working with data and science and synthesizing that. So translating, delivering climate science information that's relevant to our users. And then we are also developing and supporting tools and technologies for this decision making and planning. And we have multiple projects that are really just designed to increase climate literacy, outreach this information, bring people together, and overall facilitate engagement. Much like your partnership. That definitely resonated with me when you were talking about your mission. So our priority issues, and these change a little bit, are presented here. And we have in the past really focused more on adaptation and resilience, although throughout time, mitigation has also been somewhat of a priority. And we are entering a time where we are working very closely with NRCS on their climate smart agroforestry practices. I'll mention that once more in the presentation, and that is very mitigation focused. We also do vulnerability assessments. We're working on one now. A little bit of understanding fire risk in each of our regions. I mentioned climate literacy, and we also have a focus on climate equity, which I'm going to talk about in just a minute. What does this all mean? We have a website, we have webinars like this one, we have a webinar series, white papers, fact sheets. We do have a quarterly newsletter. It's called the Quarterly Harvest. I would love if folks could sign up for that and let me know if it's interesting to you. We are a team of scientists, so there are some peer-reviewed papers that come around every so often, and we have economists on the team. So we like to think about how some of these practices and strategies are or can be cost effective for the producers. I mentioned climate equity. We have, in the last year, the hubs have taken a strong focus in this direction. The Northeast Hub has a climate equity fellow who has worked on a toolkit to apply to each of our projects. So like, how is our work meeting climate equity goals? We also had to educate ourselves through a series of climate equity webinars, brought in a suite of next generation scientists to work on climate equity issues as well. So how to integrate that into the projects that are coming up in our realm. And we have a specific focus on tribal climate equity as well, and some art projects that are focused on this. So integrating climate equity into all our projects is what we're aiming to do here. All right, I'm jumping into the next part of the presentation. So this is what I call the meat of the presentation, right? Of the sandwich. How the climate is changing in our region, and specifically what elements of climate change may influence agricultural risk. So I think we all have a sense of global warming and temperature increases, but how that plays out across the country is quite a bit different, depending on what region you're in. And so we really think about, in the Northeast, what are we seeing? What is happening? And we are getting the warming, although a lot of the warming is minimum temperatures. Projections for maximum for maximum increases are in the works, so to speak, and I can get to that more later. But we are seeing this heat waves worsening, becoming longer duration, and that is especially an issue for the Northeast because of our urban areas. We have an extended vernal period, which of course in Vermont means extended mud season. I certainly have noticed that where I live in Peacham, we have mostly dirt roads, and it seems like mud season is just getting longer and longer. You see a lot about climate change influencing snowpacks. And yes, we are seeing a decrease in snowpacks, but with that, in some areas of our region, including the western, northern Vermont, there is some data that's showing a trend for heavier snowfalls, so bigger snowfalls. And there's but then it's melting, right? So we saw that this month. Saw a lot of snow if you're in the northern part of the state, and then but the snowpack overall for the winter was much less. So plays out a little differently depending on where you are in the region. Precipitation is huge. I'm going to talk about that for several minutes. Drought is a little bit of a mystery of whether it's increasing and how. And I have to mention sea level rise, even though we're not seeing it in Vermont, but that is a big piece of how the climate is changing in our region. Okay, so temperatures. Yes, it's warming. Yes, in the Northeast, it is warming a little faster or on par or a little faster than the rest of the world. Some of that faster is happening on the coast, and that is because of the water, most likely because the influence of the increase in temperatures of the ocean is increasing the land surface temperatures as well. This is on the right there is the graph that's showing an average temperature increase across the year, so that's annual, and we see this trend pretty remarkable for increase in temperatures. But I would say most of us already knew that. What we maybe is a little less known is that how are these temperatures changing? And we see that winters are warming faster than other seasons. This is Millinocket, Maine, and you can see temperature change. The x-axis there, January, February, starting out, yep, big temperature change. Not so much when you get to April, May, June, July. When it starts up again in August, September, and really shoots up November, December. So that is actually somewhat typical for what we're seeing across the region. Is winters are warming faster, and you see that that's not the case everywhere. So the map on the right is national level warming, and you can see we are seeing that more than other places. Growing season is fascinating. Someone just minutes before this talk sent me a message that they are not seeing growing season increase at one of their weather stations in New Hampshire. But regionally, we are seeing this increase in growing season, and that's the number in the growing degree days as well, which I'm going to talk about in a minute. It has increased, and you can use this tool. It's called freeze date tool. I bet if you look that up, you'll find it. It's created out of the Midwest Climate Hub. And the idea here is that in recent years, the final spring frost has been occurring earlier than any other point since 1900. And the first fall frost has been arriving later. So that's a longer growing season, which means more green time for more growing time. But it also changes, it influences pests and weeds as well as those things that we want to grow. It's a really important piece to it. Whoops. And shift in hardiness zones as well. So as we're experiencing the shifting temperature dynamics, the warming of the average annual minimum temperatures, these minimum temperatures are super important for determining what plants will survive the coldest winter conditions in any given place. So we use these temperature trends in this way of, you're probably pretty familiar with this, these plant hardiness zones. So USDA uses these temperatures to create these zones. And anybody who's put a tree or any kind of perennial plant in the ground really pays attention to this zone system. What you might not know is that these zones are based on a 30-year average temperature trend. And so as the winter temperatures warm and we hit those low temperatures less regularly, we can see that reflected in the plant hardiness zones. So the USDA just recently released this new map, which you can see on the slide. And what this map does is it uses finer resolution spatial data from more weather stations and more sophisticated modeling. And it shows us that since 2012, about half of the country has warmed to the point that they have shifted at least a half a zone. So if before you could plant rate anything that was rated to 8A, for example, you can now plant anything that could survive in 8B, half a zone. Fascinating. Many of you already know what a growing degree days, the concept of growing degree days, but for those who don't, I want to just pause and talk about it for a minute because it's a really important concept. In a nutshell, growing degree days are also known as heat units, and we use them to estimate when any given growing season crop will develop, or when a pest or other insect may go through different life stages. We use this formula that's on the slide here for keeping track of growing degree days. So you take the max temp for any given day, add it to the min temp for that day, and divide by 2, gives you an average temperature for a 24-hour period. Then you subtract what we call base temperature. Most of the time we use a base temperature of 40 to 50 degrees, but different species have different base temperatures associated with them, but it's usually between 30 and 50. And that equation will give you a growing degree day value for a single day. So then you start on January 1st, and you just keep adding your growing degree day values one on top of another. So by May 1st, you might have 72 accumulated growing degree days. By July 1st, you might have 900. And that's how it works. And so you'd use this information to learn what you know, take what you know about a species, like spotted wing Drosophila. We know that the first generation of adults are likely to emerge at 510 growing degree days, and they peak at 755. So in theory, you may want to set your monitoring traps out before the 500 and keep tabs on the population. And so this helps us, this is like a tool to help us adapt and manage. All right, so we're going to move from temperature into precipitation. We know that an increase in CO2 and other greenhouse gases in the atmosphere is causing this radiative forcing, which results in a global mean temperature rise. We see that in our region, but also 1 degree Fahrenheit increase in temperature means that the atmosphere can hold 4% more water, or you sometimes hear it in Celsius, 1 degree Celsius, 7% more water. This means that the intensity of storms is increasing. So just a bigger bucket can hold and dump more water. And this is part of why we're getting these bigger storms, heavier rainfalls. And that is happening in our region more than any other place. We're seeing this increase in precipitation, and it is more alarming than it is for temperatures, really. This graph shows summer, but this is for our whole region. And you can do this out for each state. I was actually doing it this morning for Vermont, and you can do it for different seasons. And it's actually an increase throughout the year. And this extreme precipitation is especially interesting. So on the right, we see 60% increase in the Northeast. That's of heavy, extreme precipitation events. And that's defined as the top 1% of events. And that is increasing again over all seasons. And on the left is a new graph from the 5th National Climate Assessment that shows that we're seeing this increases in averages. We're seeing this increase in intense rain events. And for flooding, we think a lot about how much rain comes all at once. So a 2 inches in a day is increasing. That's the upper left. But in the lower right, we're seeing 5 inches in a day is increasing even more. Again, unique to our region, really. Maybe not entirely unique, but it's happening more so in our region than other parts of the country. I said I'd mention sea level rise. It's really affecting our region, perhaps not so much in Vermont, but farms and forests experience this increase in salinization, which really affects their growing options and can create ghost forests. And we're seeing that in parts of the mid-Atlantic. Okay, this is one that people are often really interested to talk about. Okay, so we're seeing more drought, more rain. Are we seeing more drought? And I think that's an important question to ask. We've been investigating this quite a bit, and I'm going to share some data with you, and we can figure it out together. Drought's one of those things that can be difficult to define. It's somewhat subjective, has to do with supply and demand, lack of rain, has to do with how much runoff we have, moisture supply. So when considering how climate change is increasing drought, which we often hear, and we think about it in our region, we see, okay, well, hydrological droughts have become less frequent since the 19th century, and that's due to increases in precipitation that compensate for the warming driven increases in evaporation. And the question is will that keep happening as temperatures are projected to increase? And this change in drought conditions, this map, is showing that the brown is becoming drier. That's many portions of the West. And then there's a lot of blue or blue-green across the rest of the region. And this is really factors into how things are experienced on the ground as well. So if you look at the left, there's all these different definitions of drought, and then everything is somewhat averaged over in a few different ways when you look at the standardized precipitation evapotranspiration index and the data. So let's get into that a little bit more. This study found that drought's becoming less frequent in our region. The blue here is less drought, but the intensity and duration of drought aren't changing as much as might be expected with the increase in rain or precipitation in the region. So just look at Vermont for a second. The frequency is the upper right, decreasing. Yep. Rest of the region, yeah. But intensity in the southern part of the state and duration, intensity is over on the left-hand side. Yeah, there's a little bit of increase there, and duration too, a little bit of increase. Fascinating. Okay. This is a quick analysis that we did where we're asking the question, okay, if more rain is coming, but it's coming all at once, couldn't we also have more dry days? Couldn't you have more rain and more drought? Because the increase in rain is coming all at once. But this study says, look at the data, it's not really a study, it says no, the number of dry days calculated from days since rain is decreasing. So we're actually seeing more rain, and we're seeing it on more days. But a little bit of yellow spots in there. There's not in Vermont, but in our region. And so I think there's still some question there. And what is the projection? This is just trends. So we looked again, we partnered with the National Drought Mitigation Center on analyzing drought trends across the Northeast. And we found, yep, increase in winter and spring precip, increase in heavy precip events, no clear regional change in dry periods, very similar to other studies. We did find that days with snow on the ground, again, that snowpack for at least February is decreasing. And snowfall has decreased across the region, but like I mentioned, there's some increase in places in inland and northeastern New England. I think that there's a lot of future work to be done here. We can examine the maximum lengths of dry periods each year, the number of periods that meet a certain threshold. And the robustness of these results is very sensitive to what time period we analyze. So when you start the time period and whether you started in a drought, for instance. I get a lot is if rain comes all at once and that rain doesn't actually infiltrate the soil rapidly enough to be captured, that runs off, then it's ineffective. So maybe soil moisture is a better way to understand drought. And I think this could be a key to understanding our conditions. In NCA 5, we see that there is a projected change in summer soil moisture, and by mid-century, by mid-century as compared to the last 30 years. There's this projected decrease in summer soil moisture. So it's really brown in most of the country, and including the Northeast. That could tell part of our story of what we're going to be seeing for issues with farms. Similarly, as we have the moisture available and the temperatures are rising, there's a projected increase in evapotranspiration. Also, this is mid-century as compared to the last 30 years. And this is one of those questions of, will the precipitation outpace the temperature or vice versa? All right, moving into the next part. I don't want to linger too long on impacts because I feel like most of you already know the impacts, or you hear it from the farmers that you work with. I think the farmers tell the stories much better than I do. However, just to get the context going here, we really focus a lot on this increase in rainfall, this increase in precipitation intensity, helping find ways to deal with erosion, compaction, loss of nutrients, all of those aspects that come with the flooding. With increased temperatures, we deal a lot with fault springs, where the temperatures warm so much in the winter that you end up with your fruit trees budding in February, and then of course you get snow again, and you get frost, and that damages and really sets things back. There's also similarly issues with the pests and the weeds, and potentially needs for more irrigation. And then we have studies on salinization as well. And again, with adaptation strategies, I like to hear the stories from the farmers, but a lot of this is similar to what you would do in just as a conservation practices, promoting soil health, reducing soil erosion, increasing the ability to make decisions, better decisions, well, decisions with better information faster. So having the tools, watching the weather more carefully, protecting the farms, the crops, the livestock from the extremes. These are just some examples, but this is a lot of what the context of the Climate Hub information is we collect these stories, we talk to farmers, we figure out what the solutions are, maybe who's being innovative, what the economics are behind some of these. I mentioned a lot of these are what we already do for soil conservation, and I just wanted to dig into that a little bit more, which is that it's like what we would normally do for other benefit also increases the resilience and reduces the risk for farmers in a changing climate. So improving soil structure, for instance, is something that makes a difference for resilience. Similarly, using mulch, cover crops, leaving crop residue on the ground. These are actually the most prominent strategies for climate resilience and for soil conservation. So it's very, very similar. Now I want to get into some strategies. And I talked about this with the partnership earlier, a subset of the partnership, I guess. And there was a lot of interest in these shallow wells. So here's just an example of one of these innovative solutions that's being tested. And the idea behind this is that a farmer may build economically be able to build a shallow well on their farm. It diversifies access to water in times of in times of drought, but also takes advantage of the increased precipitation. So it's holding that water, storing that water more than a traditional dug well would. And this is being considered anyway for one of the NRCS climate smart strategies, and it could be very cost effective. We also have an active peer learning program in the region with many participants that are currently in Vermont. And we have a dairy farming program, but we also have a diversified specialty crop program. There's a row crop program in the Midwest as well, and a women and non-binary farmer program. And this supports these farmers and agricultural service providers in implementing both climate adaptation and mitigation practices. And the idea is that these fellows, we call them fellows, it's like a fellowship program, are well trained and then deliver the message or outreach the message as they develop adaptation plans to their peers so that it is spreading across the region. Basic suggestions I have for resources is these NOAA climate state summaries. They're 4 pages and really specific to the state. I think it's one of the best resources out there to get at this question of how climate change is affecting the individual states. Another decision support tool is this Ag Risk Viewer, and the purpose of the viewer is to allow someone to explore, visualize, and analyze data that's crop insurance data, and this is all publicly available from USDA Risk Management Agency. You can actually see what the risks are by looking at the crop insurance data. It really tells us what is happening in our county. We also have a cover crop species selector that I think can be pretty useful. It allows the user to identify what cover crop species is most appropriate for a given field based on whatever the goals are, the farmer's goals are. So you put in, the input is, what are your goals? Improving organic matter, preventing erosion, nitrogen fixation, etc. And then the program actually selects some options for your area. One of the best ways to improve decision making, I mentioned this earlier, is using climate information or from weather station data. So really seeing how the weather, tracking how the weather is, how climate change maybe is playing out in the weather at your specific location. And so matching how weather is changing or how the weather is fluctuating with a whole suite of tools is what this program does. This is new, a Network for Environmental and Weather Analysis. And if you select a station that's near you, you can actually see, for instance, how management for some of these diseases and pests can differ. And there's also climate smart farming tools, growing degree calculators, and that sort of thing. This is also those tools are also set up with scan data as well, if you know of other types of weather stations that you have near you. I like to mention this. We have some, I mentioned fact sheets in the beginning of the presentation. We did an analysis on farming in the floodplain, and I always like to bring up this concept of trade-offs. So when we think about how we're adapting to climate change, building resilience is only one of many goals. Sometimes they're in line with other goals, and sometimes there are trade-offs and barriers. And so this does a good job describing that. So in New England, these river valleys are the places where farms
ahí, vos en este momento
often
llegás y
are.
empezás a decir que tengo todo desordenado.
And that's because that's where the soil is more fertile, right? And it can be cultivated, and where flooding is also more common. And so this kind of goes through the different practices for resilience specific to flooding and what the trade-offs are. So I mentioned we're working with the Natural Resources Conservation Service, NRCS, on their list of climate smart agriculture and forestry practices, conservation practices. These are for climate mitigation. So greenhouse gas reduction, increase in carbon sequestration. And there is a lot of research that's still needed to monitor and confirm the benefits of these practices. So we are engaging a 5-year project with NRCS to increase climate literacy for those who are helping implement these practices, the technical service providers, and evaluating the outcomes, or evaluating, so that when we're working with farmers and landowners on these practices, we have a better sense of what they are truly doing to benefit climate conditions. Wanted to point out the 5th National Climate Assessment. This is just came out in November. It was updated from the last one we did in 2018. I'm an author on the Northeast chapter, so I always like to throw that one out there. The precipitation graph is from that publication. But there's also chapters on agriculture and water that might interest you. These are online, very visually appealing, written to be accessible to a very broad audience. The NCA in particular addresses climate change impact to our country. So the interactive atlas is so cool. You can select state-specific information and explore the same data that we used for the analysis in NCA. to see how climate change will play out or is projected to play out in Vermont, for instance. So I would love to accept any questions that folks may have if we have time for that.
Thank you so much, Erin. That was great. Folks, feel free to, oh, my video is not. Feel free to either unmute, turn your video on, and ask a question, or if you want to put it in the chat, we can monitor that as well. And Erin, there was a comment, if you scroll up in the chat, about meeting folks from the Climate Hub. I don't know if you got to see that while you were presenting.
I saw that. I'm so glad to hear that you were able to meet with our counterparts in the Caribbean. Oh, and they were in the Virgin Islands. Fantastic. That's great. Yeah, we have several projects that are cross-hub. I think a couple of those that I presented today originate in another hub, and we kind of bring them together or make them more regionally specific. Some of these issues just aren't regional, or maybe they have a regional twist to them. And so we work together to create those projects, tools, solutions.
So Erin, in the Vermont Ag Water Quality Partnership, we're in our last year of our 5-year strategic plan, which I kind of touched on a few of the points in the beginning, which is very much focused on water quality and wildlife habitat. But as we look ahead to our next strategic planning for the next 5 years, we're definitely considering how does climate or climate co-benefits play a factor in that. And just hearing this, what would you say, in your opinion, might be our maybe top 3 areas we might be looking at in terms of kind of our collaborative planning for the future?
Oh, that's a tough question. So, well, I mean, I think a lot of when I think of water quality, it's like flooding and drought, right? And I think both are important for consideration, and honing in on how those impacts are affecting not just we focus a lot on production, but if you think in terms of water quality as well, there's some aspects there that haven't been, I mean, I'm sure somebody is working on that. That's not something that we as the hub have focused as much on because we're so focused on production. And I know folks at UVM have done fantastic work in that regard, and thinking about focusing in on those events and how they're increasing or changing, and then how that's going to affect water quality, and then coming up with, like, just understanding that alone is probably worthwhile as a goal, but then also thinking in terms of what the strategies are or the innovative solutions, again, going to have co-benefits with other aspects of our work and changes that we're seeing. But as far as partnerships go, I mean, you all are probably already working with so many folks in the region that are focused on this. Of course, the land grants. I wonder if there is a connection to the work with NRCS and the climate smart practices. I know John was on our last meeting, but I think that because we are going to be so focused on that, I wonder if there's a interest in maybe reutilizing some of the climate literacy materials that we're creating for NRCS. It seems like it would be applicable to you all as well.
Thank you. I'll let Erin, there's a comment in the chat. I'll let you take that.
So that's a great point. Yeah, that's a good question, Bruce. So the question is there a list that is analogous to the climate? When we say climate smart practices, it can mean in general, broadly, it can mean both adaptation and mitigation. And a lot of practices meet both. In this case, this list is designed with mitigation in mind foremost. The adaptation practices are more integrated into the broader conservation practice list that NRCS already has. And like the climate adaptation or the resilience benefit is kind of integrated into that. So there is no separate list. Well, actually, that's not true. There is part of that list is identified as adaptation strategies for climate change, but it's not, it's like, that's what ends up being a co-benefit to benefit the farmer. Whereas the climate mitigation list, the co-benefit benefits the world, society, right? It's a public benefit because we're sequestering more carbon or emitting less greenhouse gases. It's a good question though, and I think that we actually just discussed that at one of our meetings yesterday, is how these two lists come together, because so many of the practices meet both adaptation and mitigation goals. And if there's anybody from NRCS on who wants to add to that, I would welcome comments.
Tom Aiken was on, but I guess he's not paying attention, but doesn't matter. I want to follow up on that one a bit. I mean, you're right that many of these practices are, the NRCS practices on this climate smart list are indeed both adaptation and mitigation, but the list is primarily, it was designed as a mitigation list. There's been a lot of extra money spent on the things that are on that list that aren't on other lists. And which is great, but it's also, I would make the argument that adaptation and resilience are equally important for the common good. That is, we need to be able to continue to produce food, and that I would actually like to see the climate hubs and NRCS and everyone else getting, putting more money toward adaptation, basically. So we've been putting money toward mitigation. For most people in the world, mitigation is about reducing greenhouse gas emissions, i.e. cutting fossil fuel use, which is great. But for agriculture, that's a really tiny piece of the whole puzzle.
Mm-hmm. Yeah, and I would actually add to that it's, there's a little, because I study soil carbon, I think that there's actually more unknowns in that than, there's more known about the benefits of adaptation than there is about the benefits of mitigation practices and actually the research and science behind it. So I'm agreeing with you, Bruce. I don't see the hubs shying away from adaptation. We've always focused more on adaptation. I shouldn't say that. It's overall through time, through the 10 years that we've been, if you did a pie chart, adaptation would take up would eat a lot of the pie, and mitigation would be a smaller section. And this is Infrastructure Reduction Act funding that comes specifically for climate mitigation. I don't see us focusing solely on mitigation. I think adaptation benefits will be part of the discussion and part of the training. It'll infiltrate the conversation.
Erin, I see a question in the chat. It says, can you speak further on ways for conservation districts to engage and assist with the climate hub's work and projects?
I love that question. I'm very interested in that. Part of our challenge is that we are regional. And so, and we have 12 states. That's more than, it seems like that's more than any of the other hubs. Their states are bigger, but we have a lot of these little states, and plus DC. And so then I've never counted how many conservation districts we have in there. That would be a project. But there's several conservation districts. And so being able to meaningfully engage with a conservation district is a challenge, just like it's a little bit difficult for us to meaningfully engage with 12 states. But what you all are doing, what the conservation districts are doing, and the capacity that you have is something that we would love to collaborate with, leverage somehow. Some of our funding we say, oh, a conservation district would be able to use this and to meet the mission so much better than we can. but again, it's that scale challenge. So I'm interested in finding ways to work with conservation districts and more. And maybe there's a way that we can structure it so that we can involve multiple conservation districts or on a more regional level. Good question.
Kind of following up to that question, what would be a good connection point if somebody was wanting to kind of engage in some of that work? Is where should they be directed?
If you're in the Northeast region, I think emailing me is probably the best way to go for somebody from our team, so that we can start having these conversations. I also think that we're hoping to connect conservation districts through this climate mitigation outreach and education project with NRCS. And I think that may be another way that we can bring them into the conversation and with the projects. Here, I'll put my email address in the chat box.
Thank you. All right, any other questions for Erin before we wrap up?
Hi, Ellie. Hi, Erin. Thanks for answering that question, Erin. I recently became aware of a project that's going on out of the Montana Climate Office they're doing like a mesonet, or like placing climate monitoring stations at like different places across the state just to create a really dense like tracking system for like climate data. And I was curious if there's a similar effort or like push for that kind of thing in the Northeast for kind of increasing the number of climate monitoring stations we have and how that could help with getting like precise data for different parts of our states.
There is. So the one that I'm most familiar with that's really exciting and presently making a splash is our Northeast snow monitoring study. And if you haven't heard about that yet, it's pretty exciting because out west, they have all these snow tell sites. They're part of the NRCS scan network. Well, they're similar to the scan network, but they measure snowfall. We have a dearth of data on snowfall. And so there's this feasibility study happening right now on increasing the number of snow tell sites in New England specifically. And if somebody from Vermont, I can't think of anybody right now, but I'm sure somebody from Vermont is part of that group. I was just looking for a link and I didn't see anything, but there should be something coming out soon. Northeast Snow Monitoring Study, I believe is what it's called. So that is happening. And then otherwise, we've more been focused on bringing together all those weather station data networks. So there's the Mesonet and there's the NUA I mentioned, and there's the scan station. So I'm not going to say we have enough weather stations. I don't think you'd catch me saying that, but bringing them all together so that you can synthesize and analyze the data is what we've been working on. And that has been mostly with the Northeast Regional Climate Center, who are close partners of ours with at Cornell, but through NOAA. And so I'll put their site up here, and you can find out more about how they bring together the data and then also connect that to tools so that when you're looking at one of these past calculators, for instance, you're using the best weather station data regardless of which network it's part of.
Thank you.
All right. Well, thank you so much, Erin. This was great, and we really appreciate all of your time and your information in the chat so folks can follow up. So thank you.
Thanks for having me.
Thanks for everybody who joined today. Please be sure to complete the survey. Thank you all. Have a great day.